There's never been a better time to be in the computer industry. Despite the challenges, it's still a terrific place to work with opportunities to build useful things and to push the frontiers of what's possible with technology. You may have also heard that despite the thousands of computer science students graduating from colleges and universities around the world, only a small number are actually employable at most organizations. Why is this, and what can we do to change it? One of the root causes of the shortage of employable graduates is simply because of the difference between what schools and colleges teach versus what students actually end up doing on the job. If you ask a computer science student what their jobs might be like when they graduate, they might tell you they're excited by the idea of programming new software, or maybe even fixing computer networks and hardware. But of course, what happens in most organizations is quite different from that. I think the way we teach computer science today needs a makeover. Today things are taught in an unnecessarily complicated way, and the focus is very largely on computer programming. Whilst that is the very foundation, it takes a lot more to succeed in this profession. The goal of this series of videos is to convey through simple explanations the big picture of what really goes on in an organization, and that it takes a lot more than knowing how to program software to succeed and to move up in your career and to be successful in this profession. So let's do things a bit differently here. Let's break down the whole subject into small bits and study each area through simple explanations, and then put it all together so you can see the big picture. The format of these videos has been inspired by some wonderful work done by the Khan Academy, and I hope you get a few minutes to visit it. Let's start by looking at the types of things that computer programmers make. There are many, but broadly they can be categorized into three main buckets. Operating systems, the smallest bubble, employs the fewest number of people in the industry. Examples include things like Windows 7, Mac, which help run your computers and laptops, and software like Android that run your smartphones and tablets. Embedded software are things that run inside machines, such as cars, to control the engine. They help planes to fly and land safely and keep food cold in your refrigerator. User software is the largest bubble and represents things like websites, business applications such as those used by your phone company to calculate your monthly phone bill, personal applications such as listening to music, typing documents, creating spreadsheets. Let's call this whole group applications. We will focus on this category of software as it is the one that employs the greatest number of people and also faces the highest number of challenges. So what do computer professionals actually do? We are now ready to take a quick peek into answering that question. They help create new applications or customize existing applications, and when they're ready, help users to use it. They enhance it to make it better, and after many months or years of using it, they help to replace or retire it. When an application is being created, it costs the organization both money and time. When it goes into use, the organizations make money or save money by having users use it. Organizations continue to invest more money by making enhancements and changes to keep making it more and more useful to users. But as it gets older, its value gradually decreases, and at some point it costs the organizations more money to keep it going than the value it earns from it. At this point, the organization replaces or retires the application. Organizations continue to find ways to do more with scarce resources such as time, money, and people. That means looking for ways to produce the same things quicker and cheaper. The same thing applies to creating and managing applications. Organizations are always trying to find ways to reduce the cost and time needed to create new applications. Increase the length of time that an application is in use before it needs to be replaced. Increase the value of the application so that users might use it for longer and use it more frequently. Applications need people and hardware infrastructure to keep it running. Organizations are looking to keep these support and maintenance costs as low as possible. When it comes time to replacing or retiring the application, organizations are looking to get rid of them as quickly and as cheaply as possible. So you can see that software programming, while it's important, is only one aspect of the whole life of managing an application from start to end. Most organizations often have more than one application. They typically have tens, hundreds, and sometimes even thousands of such applications. To truly see what's going on, we need to step back and look at a wide range of topics, from the various ways to explore users' requirements, design software to reduce the time and cost of building, testing applications, how to lead software and development teams, and manage projects. We will look at ways to increase the value of applications already in use, how to decrease the support and maintenance costs, and what it takes to safely replace and retire aging applications. And finally, we'll touch upon risk management. Lots of things can go wrong with applications. Projects can fail, credit card information on the website can be stolen or compromised. The organization's reputation can be harmed if monthly phone bills are all produced incorrectly. So computer professionals are required throughout the application's lifecycle to keep these risks from hurting users or the organization. Eventually, we will look at what it takes to manage the whole IT department. I hope to inspire you to see the big picture of what really goes on in an organization and what you need to know to succeed and move up in your career. See you in the next video, where we will look at an application and how it gets built from start to finish.